valence shell electron pair repulsion theory, that is what you called as VSEPR theory. According to the VSEPR theory, this is 180. Then the angle suggested by the trigonal planar electron pair geometry is 120. Because according to the VSEPR theory, electron pairs are oriented in 3D space in order to minimize their repulsion. If you have 4 VSEPR pairs, then that is tetrahedral electron pair geometry. Okay, that is tetrahedral electron pair geometry. So it is 109.5. Okay, so if you have 2 VSEPR pairs, then 180 degrees. If you have 3 VSEPR pairs, then it is trigonal planar, right? And it is 120 degrees. If you have 4 VSEPR pairs, it is 109.5. 3 different angles in trigonal bipyramid electron pair geometry. 90 degrees, then 120 degrees, and 180 degrees. Okay. Then the sixth one, that is what you called as octahedral electron pair geometry. Angle between all the electron pairs 90 degrees. Okay, angle between all the electron pairs 90 degrees. Any two electron pairs in the axis, then that is 180 degrees. Okay, that is 180 degrees. What are the three different types of repulsions? You have LP repulsion. That means lone pair repulsion. That is the strongest type of repulsions among all the repulsions. Then you have lone pair bond pair repulsions. Lone pair bond pair repulsions. Then you have bond pair repulsions. Then you have bond pair repulsions. So here you have one bond pair repulsion and two lone pair bond pair repulsions, right? Two lone pair bond pair repulsions. Okay. Two lone pair bond pair repulsions. You don't have lone pair repulsions in trigonal planar electron pair geometry, but you have lone pair bond pair repulsion because you have one lone pair and two bond pairs. So you have two lone pair bond pair repulsions and one bond pair repulsion. Lone pair bond pair repulsion is stronger than bond pair repulsion to minimize the repulsion, stronger repulsion. To minimize the stronger repulsion as much as possible, what happens? Bond pairs get closer to each other because bond pair repulsion is weaker. So weaker repulsions, bond pair repulsion is weaker, so they get closer to each other. But lone pair repulsion, in order to minimize the lone pair repulsion, okay? In order to minimize the lone pair repulsion, two bond pairs get closer to each other. And what is the value has to be subtracted? It is 1.5, right? It is 1.5. So 1.5 degrees has to be subtracted. 1.5 degrees has to be subtracted. So it is 118.5. It is 118.5. Okay. As a summary so far, 2.5 degrees should be subtracted for the each non-bonding electron pair present in tetrahedral electron pair geometry. And 1.5 degree has to be subtracted for each non-bonding electron pair present in trigonal planar electron pair geometry. Okay. So, මේ question එක ඇහුවා 2018 වල, right? 2018 වල මේක ඇහුවා. අපිට ඉස්සරහදී හම්බෙයි. Example එක තමයි NO2 minus එකයි, right? NO2 minus එකයි NO2 එකයි. This is NO2, right? This is NO2 and this is NO2 minus. Okay. This is NO2 minus. Okay. This is NO2 minus. So this is NO2 minus. So which one has a greater bond angle? Here you have single electron bond pair repulsion and here you have pair of electron bond pair repulsion. Pair of electron bond pair repulsion is much stronger than single electron bond pair repulsion. Much stronger. Okay, much stronger. This one has greater bond angle. Why this one has greater bond angle? Why this one has greater bond angle? Because the repulsion is weaker. Okay. Single electron bond pair repulsion is weaker. Pair of electron bond pair repulsion is stronger. Because of the stronger repulsion, in order to minimize it, bond pairs get closer to each other. Then methanadi. So basically, you have two different types of repulsions between lone pairs when the electronegativity of the surrounding atom and the middle atom is changed. Okay, lone pair bond pair repulsion is approximately equal in these two molecules. Okay, lone pair bond pair repulsion is approximately equal in these two molecules. Here you have lone pair bond pair repulsion, and here you have lone pair bond pair repulsion. So the lone pair bond pair repulsion is approximately equal in these two molecules. It is approximately equal in these two molecules. You have different electronegativities for terminal atoms, or else you call that as surrounding atoms. So you have different electronegativities for terminal atoms or surrounding atoms. Right. If you consider the electronegativity, Fonkel rule, F-O-N-C-L, Fonkel rule. If you consider the electronegativity, the Fonkel rule is applied. Fluorine is the highest electronegative, oxygen lesser than that, nitrogen lesser than that, nitrogen is equal to chlorine. Nitrogen is equal to chlorine. When bond pairs get closer to the middle atom, then you have stronger bond pair repulsions. So here, bond pair repulsions in NH bonds is stronger than the bond pair repulsions in NF bonds. Okay, bond pair repulsion of NF bonds. So you have greater bond angle in NH3 than NF3. You have greater bond angle in NH3 than NF3. Okay, you have greater bond angle in NH3 than NF3. Bond pair repulsions of OH bond is stronger. So the bond angle of water, right? Bond angle of water is greater than hydrogen sulfide. Okay, that is the ability to attract bond pair electrons towards itself. That is what you call as electronegativity. Electronegativity values, specific values for electronegativity is given by the Pauling scale. Okay, here electronegativity increased by 0.5. So here electronegativity increased by 0.5, and here electronegativity increased by 0.3 up to this value. Up to phosphorus it is increased by 0.3, then it is increased by 0.4. Okay, 0.3, then it is increased by 0.4, then it is 2.5, then it is increased by 0.5, then it is 3. Okay, why electronegativity increases when move across in a period from left to right? Why? Because nuclear charge increases. So when the nuclear charge increases, then what happens? You have greater attraction to the bond pair because nuclear charge is increases. So nuclear charge increases means you have greater nuclear charge for the oxygen atom relative to nitrogen. So you have greater attraction to the bond pair electrons. There are 4 factors change the chemical environment of a particular atom. First one is hybridization. So priority should be given for the hybridization. Priority should be given for the hybridization. That is the first factor. The second one is charge on atom. Charge on atom. Second one is charge on atom. Okay, charge on atom. Charge on atom. That is the second factor that change the chemical environment of a particular atom. Change the chemical environment of a particular atom. Then the third one, first one hybridization, second decker charge on atom, third decker oxidation state. Third decker oxidation state. So oxidation state of an atom also change the electronegativity of a particular atom. The final one, the atoms those are attached with a particular atom that is interested.